नमस्कार विद्यार्थी मित्रांनो, स्नेहदीप कोचिंग क्लासेस या YouTube चॅनल मध्ये आपले सर्वांचे मनपूर्वक स्वागत. Today we will see the characteristics of the groups and the periods in the modern periodic table. This is the modern periodic table. Student, we see S block, P block, D block and F block elements. Now, characteristics of the groups and periods. The characteristics of the groups and periods in the periodic table are understood by comparison of the properties of the elements. एलिमेंटच्या प्रॉपर्टीजचे कंपॅरिझन केलं की आपल्याला ग्रुप्स आणि पिरियड यांचे कॅरेक्टरिस्टिक लक्षात येतील. व्हेरियस प्रॉपर्टीज ऑफ ऑल द एलिमेंट्स इन अ ग्रुप शो सिमिलॅरिटी अँड ग्रॅडेशन. However, the properties of the elements change slowly while going from one end to the other, that means from left to right in a particular period. In the modern periodic table, elements are arranged in an increasing order of their atomic numbers. Vertical columns are called groups. There are 18 groups. The chemical properties of the elements in the same group show similarity and gradation. एकाच ग्रुप्समधील एलिमेंट्सच्या प्रॉपर्टीज ह्या सेम असतात. Horizontal rows are called as periods. There are in all 7 periods. The properties of elements change slowly from one end to the other in a period. मॉडर्न पिरियडिक टेबलमध्ये 7 पिरियड्स असतात आणि ह्या 7 पिरियडमध्ये एलिमेंटच्या प्रॉपर्टीज एका मूलद्रव्याकडून दुसऱ्या मूलद्रव्याकडे म्हणजेच लेफ्ट टू राईट, एका मूलद्रव्याकडून दुसऱ्या मूलद्रव्याकडून तिसऱ्या असं लेफ्ट टू राईट स्लोली चेंज होत असतात. इन द मॉडर्न पिरियडिक टेबल, uranium has atomic number 92. All the elements beyond uranium with atomic number 93 to 118 are man-made. All these elements are radioactive and unstable and have a very short life. Now we see modern periodic table and electronic configuration of element. First point, within a period, the neighboring elements differ slightly in their properties while distant elements differ widely in their properties. Within a period, the neighboring element differs slightly, very slightly difference आहे, but अतिशय कमी थोडासा डिफरन्स आहे नेबरिंग एलिमेंट. बट व्हेन वी कन्सिडर द डिस्टन्स एलिमेंट्स अवे एलिमेंट फ्रॉम ईच अदर, therefore the widely difference. For example, we take a lithium second period, third period, sorry. In third period, lithium and beryllium is a neighboring element. When we see the properties of the lithium and beryllium, there is very slightly difference. But when we take the properties of the lithium and fluorine, same period, third period, lithium and fluorine, there is a wide difference in the properties. शेजारचे दोन घेतले तर प्रॉपर्टी मध्ये थोडासाच फरक असतो, पण जर त्यांच्यामध्ये अंतर वाढलं, पिरियड तोच ठेवायचा सेम पिरियड, पण असं अंतर वाढलं दोघांमधलं तर मात्र त्यांच्यामधली प्रॉपर्टी मधला डिफरन्स हा खूप मोठा असतो. सेकंड पॉइंट, एलिमेंट्स इन द सेम ग्रुप शो सिमिलॅरिटी अँड ग्रेडेशन्स. सिमिलर पॉइंट आहे. आता आपण पिरियड बघितला, आता आपण ग्रुप बघूया. elements in the same group show similarity and the gradation. Same group बघितला. For example, group first, hydrogen, lithium, sodium, potassium. The properties of lithium is similar to sodium and properties of sodium and similar to potassium, or the properties of the potassium is similar to the lithium, because all of these elements are in the same group, that is the first group. Similar way we take second example. Second group, beryllium, magnesium, calcium. Properties of beryllium similar to properties of magnesium, properties of magnesium similar to calcium, properties of calcium similar to beryllium. Similar to, we take a group 17, fluorine, chlorine, bromine. Properties of fluorine and properties of chlorine and properties of bromine are similar because they are same group. This is the 17th group. Same group. This is the second group. Same group. This is the third group. Properties of the element which having in the same group is similar. Third, these characteristics of the groups period in the modern periodic table are because of the electronic configuration of the elements. These characteristics of the groups and periods, because of the electronic configuration. It is the electronic configuration of an element which decides the group and the period in which it is to be placed. What is the help of electronic configuration? Which element is placed in which place is depend on the electronic configuration of that element. Suppose आपण एखादा एलिमेंट घेतला तर तो एलिमेंट मॉडर्न पिरियडिक टेबल मध्ये कोणत्या ठिकाणी ठेवायचा हे आपल्याला इलेक्ट्रॉनिक कॉन्फिगरेशन केल्यानंतर समजते. नेक्स्ट पॉइंट, that is the groups and electronic configuration. Groups and electronic configuration. In the groups and electronic, what is the relation between the groups and electronic configuration? Our textbook page number 22. Go through the modern periodic table and write the names, the one below the other of the elements of the group first. Write the electronic configuration of the first 4 elements in this group. Which similarity do you find in the electronic configuration? How many valence electrons are there in each of these elements? Now, we see these examples. First group, second group, 17th group. Our point is groups and electronic configuration of the element. So, we will take the first group, second group and 17th group for example. एकदा हे तीनही ग्रुप तुम्हाला विद्यार्थी मित्रांनो समजले की टोटल पिरियडिक टेबल समजायला सोपं आहे. The atomic number of the hydrogen is 1 and electronic configuration is 1. The atomic number of lithium is 3 and electronic configuration is 2, 1. Sodium atomic number is 11, 2, 8, 1. Potassium atomic number is 19, therefore 2, 8, 2, 8, 8, 1. 2, 8, 8, 1. Now we take second example, second group. Group second, group 17. Group second, beryllium have the atom number 2, that means 2, 2. Magnesium having 12, 2, 8, 2. Calcium 20, 2, 8, 8, 2. Fluorine 9, 2, 8, 2, 7, 17, 2, 8, 7, and last one is the bromine, 2, 8, 18, 7. Okay. We now complete the electronic configuration. First 4 elements of the group first, third elements group second, and third element group 7. Listen carefully, students. Now we see the valence electron of the group first, valence electron of group second, and valence electron of the group 7. What is my valence electron? The number of electrons present in outermost cell is called as valence electron. Understood, all of you? Listen carefully. The number of electrons present in outermost cell is called as valence electron. Now, we see the group first, outermost cell, hydrogen having 1 electron. Outermost cell of the lithium having 1 electron. Outermost cell of the sodium having 1 electron, and outermost cell of the potassium having 1 electron. When we observe the group first and valence electron, the valence electron is same. Valence electron is same. Now we take similar example of the second group. When we observe the valence electron barium, valence electron is 2. Valence electron is 2 in magnesium. In calcium also, valence electron is 2. काहीतरी गंमत वाटते ना. सेम 17 ग्रुप मध्ये आपण जाऊया. valence electron is 7. Definition लक्षात आहे. valence electron number of electrons present outermost cell, शेवटच्या कक्षेत असलेली इलेक्ट्रॉनची संख्या, त्याला valence electron असं म्हणायचं. Fluorine 7, chlorine 7, bromine 7. 7 7 7 2 2 2 1 1 1 1. That means group first having same valence electron, that is 1. Group second same valence electron 2, and group 17 same valence electron, this is 7. That means the number of valence electron denoted the group of element. बरोबर ना? Am I right? The number of valence electron after the electronic configuration, the number of valence electron is denoted the group. For example, here valence electron is 1. So potassium put in group first. Now magnesium, here valence electron is 2. Therefore magnesium put in group second. And here chlorine, valence electron is 7. That means the chlorine put in group 17. That means 7A. That means 17. Group first is alkali metals. Alkali metals. Group second is alkaline earth metals. Alkaline earth metals. And 17 is group halogen family. Halogen family. Group first alkali metals, group second alkaline earth metals, and group 17 halogen family, fluorine, chlorine, bromine. Here valence electron is 7, group second valence electron is 2 and in group first valence electron is 1. That means when we show the group from top to bottom, here is only one cell, here is a 2 cells, here is a 3 cells, here is a 4 cells. When we observe the electronic configuration of the group first of the all elements, then we concluded that when top to bottom one cell added, top to bottom. Here is 1, here is 2 cells, here is 3 cells, here is 4 cells. When we go in a top to bottom in a particular group, then one cell added. Now we see periods and electronic configuration. We see some examples. This is the second period of modern periodic table. Lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon. This is third period of modern periodic table. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Now we calculate first electronic configuration cell wise. Now we use one example of the electronic configuration. ज्या विद्यार्थ्यांना शेल समजत नसतील त्यांनी थोडेसे लक्ष द्या. This is nucleus. This is first cell. This is second cell. This is third cell. Suppose we take example of sodium 11. 2 electrons in first cell. 1, 2, 3, 4, 5, 6, 7, 8 electrons in second cell and 1 electrons in third cell. That means electronic configuration of the sodium is 2, 8, 1. This is nucleus, this is first cell, this is second cell and this is third cell. ज्या विद्यार्थ्यांना समजत नसेल त्यांच्यासाठी already all of you seen in the 9th standard. First cell, second cell, third cell. Okay. This electronic configuration write is as this form 2, 8, 1. Now we write all the electronic configuration of the second period and third period. First we write second period. The atomic number of the lithium is 3. That means 2, 1. Beryllium 2, 2. Boron 2, 3. 2, 4. 2, 5. Oxygen 2, 6. Chlorine 2, 7 and neon 2, 8. For understanding second period example is must, but more understanding will take third period also. 11 sodium electronic configuration 2, 8, 1. Electronic magnesium 2, 8, 2. 2, 8, 3. Aluminium. Silicon 2, 8, 4. 2, 8, 5. 2, 8, 6. Sulfur. Chlorine 2, 8, 7. argon 288. Okay. Listen carefully. See on the blackboard, students. Now, when we observe the electronic configuration of the all elements in the second group, then first we observe conclusion in the configuration of the lithium. There are two cells. Here is also two. Here is also two cells. Here is also two cells. Two cells. Two cells. Two cells. Two cells. This is one cell, first, second cell, first cell, second cell, first cell, second cell, as it is, first cell, second cell, first, second, first, second, first, second. That means all the second period, two cells are present. The number of cells is 2 and the number of period is also 2. Then we concluded that the number of cells is same as to number of periods. But this is the first example. Now we take the second example of the third period and final conclusion. Similarly, observe this third period. 1, 2, 3 cells. First, second, third cells. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. When we observe the third period, examples of the third period, all the elements having one electron configuration 2, then all the elements having 3 cells. Again, all of you understand now? Number of cells is same as that the number of period. Here is number of cells is 2. All the elements. Therefore, these all elements put in period 2. In this example, all the elements having number of cells 3. Therefore, these all examples, all elements are put in period 3. In 9th standard, we see K cell, L cell, M cell, and N cell. K is the first cell, L is the second cell, M is the third cell, N is the fourth cell. This cell, K cell, L cell, M, N. This electronic configuration do according to KLMN. What is the capacity of the K cells? What is the capacity of L cell? And what is the capacity of the M cell? And what is the capacity of the N cell? Now, this is the first cells. This is second cell. This is third cell. This is fourth cell. We use the formula 2n square. 2n square. We use the formula 2n square. N is number of cells. Number of cells. Here, in case n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. In case n is equal to 1, n is equal to 2, L cell, M cell, n is equal to 3, and n is equal to 4 in N cell. Now we calculate the number of electrons in K cell, L cell, M cell, N cell. Formula is 2n square. 2n square. N is equal to 1. Put this value in this. 2 into 1 square. That means 2 into 1 square. That means 2. 2 2 into 2 square, that means 8. 2 into 3 square, that means 18. And 2 into 4 square, that means 32. Capacity of the K cell, that means first cell, is 2. Capacity of the L cell, that means second cell, is 8. Capacity of the M cell, that is 18. And capacity of the N cell is 32. Okay, all of you understand. See students, when we go from left to right in the period, atomic number 3, 4, 5, 6, 7, 8, 9, 10 increases by 1 by neighboring element. Left to right, atomic number increases 1, but also valence electron increases by 1. See in this example, atom number 11, 12, 13, 14, 15, 16, 17, 18. That means atomic number increases 1. Now we see the valence electron 1, 2, 3, 4. That means atomic number increases 1 by 1 and valence electron also increases 1 by 1.